students, good afternoon. Welcome back to the class. In the previous class, I am taking the revision class on the lesson electricity. I have told you about the resistor connected in a series combination. We got a RS, that is the equivalent resistance of a electrical circuit when connected in a series. Means resistors connected in series, the total equivalent resistance RS is equal to R1 plus R2 plus R3. That is the equivalent resistors. So we stopped for up to resistor connected in a parallel combination. So I will start with that concept. So this is an electrical circuit which showing that resistors are connected in a parallel combination. R1, R2, R3 means here same side of the resistor are connected to one end and another sides of the resistors that are connected to another end. So here at what happens, one end of the combinations are at the same point and another end of the combinations are at another point. So this is what the parallel combination. So in this case what happens, there will be a current will be divided in the electrical circuit and the potential difference throughout this circuit is same here. There is no change in the potential difference. So this will remains as it is. So for this we are applying the Ohm's law. From that we have total electrical current that is equals to I1 plus I2 plus I3. That is equal to equivalent electrical current, that is IP. Okay. So that this is what a IP for a parallel combination of the resistors. But the potential difference will be V1 equals to V2 equals to V3. That is what the total equivalent potential difference Vp. So from Ohm's law we have V equals to I into R, that we taken it as a Vp equals to I1 into R1. In this we are going to write the resistors, means resistance value we are going to calculate. For that we will take the I for this side. Okay. So what we will do? 1 by R1. So the total electrical current will be equals to I. So that is, I will write here. Okay, wait. I1 equals to V by R1 and I2 equals to V by R2 and I3 equals to V by R3. So we are going to put this value in a Ohm's law. So for this I equals to what happens? I equals to V divided by R. Okay. So this is a P. Total current, electrical current in the electrical circuit. So we are going to put these values in this equation. So IP equals to, so okay, IP is I1 plus I2. Okay. So I1 is how much? I1. V by R1. Then V by R2 and then V by R3. So here IP is there. So IP is nothing but what? Here V by R1. So V by RP equals to this one, V by R1 plus V by R2 and V by R3 here. So in this case what happens? This V will be cancels and we left with the what? I equals to 1 by RP equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So this is what total equivalent resistor for a combination of resistors when connected in a parallel combination. Okay. So you clear about this? Current will be divided, potential difference will be same here. So based on this, all the equations or the formulas that we have come across up to here are electrical current, that is what? I equals to V by Q, V equals to I by Q. Okay. Then we have Ohm's law, V equals to IR, and the potential difference V equals to W by Q, and the resistor formulas. RS equals to R1 plus R2 plus R3, and the parallel combination will be 1 by RP equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about what? All the resistors. Okay. So there is a problems. There will be given the problems based on the resistors, electric current, potential difference. For that you make some formulas, write those formulas in one side. whenever you have a problem regarding the concepts, you can easily observe the formulas and you will solve the problems easily. Okay, is this clear? Parallel combination. Then there are some applications are there when we are using, where they are using a resistors. In our day-to-day life, we are using this resistor for our electrical instruments, right? In making of the electrical circuits. So we are using these resistors. Then we have a heating effect of a electric current. So the next is a heating effect of a electric current. So what is this heating effect? As in the previous class of a magnetic effect of a electric current, I told some examples. Means in our day-to-day life we come across so many examples like electronic gadgets like a fan, battery chargers, then your laptops. When they are getting a continuous electrical current from the power supply, that will becomes heat after a certain time interval. Means after the continuation use of these objects, electronic gadgets, there will be some heat will be produced. Like the charger will be get heated, electrical fan will be get heated. Sometimes your laptops, phones, that will also get heated. In this case, what happens when there is a continuous flow for electric current, the heating means the heat will be produced inside that electrical circuits. So, but those cases the heat will not be used for any other purposes. It will be remains wasted. But in some other cases, when the electric current is passed through a circuit, whatever the heat will be produced, that is we are going to use it for some other purposes. So from that we are using applications with the heating effects of the materials. Okay, so the examples like electrical heater, micro oven. In those cases, what happens from the electrical supplies, the if heat will be produced, that heat will be utilized for our daily purposes. So this heating effect of a electric current means when there is a continuation electric current will be passes through a electrical circuit, there will be a formation of a heat. So that heat is nothing but we call it as a heating effect of a electric current. So it has some advantages as well as disadvantages. So advantages are making of a use in case of electronic gadgets. For example, what? As I told, the water heater, micro oven. In all those cases, the unwanted heat will be converted into a useful form of a heat, and that will be used for our useful purposes. Some unwanted means these disadvantages of this heating are laptops, microphones, and microphones not. Okay, laptops, mobile phones, and electric chargers. These all will be get heated due to the continuous usage. So this is about the heating effect of. So on this heating effect of electric current, scientist name called Joule, he gave the law on this heating effect of electric current. So what it states that so this heating effect is proportional to the potential difference in the electric circuit. Means how much amount of the potential difference that will be produced, that is proportional to a heating effect. So this heating effect is also proportional to the electric current. Okay, so how much amount of a current is passed in the electric circuit, that will be directly proportional to heat produced in that circuit, and this heat is also proportional to what? H. This heating effect is directly proportional to T. Okay, so on all these conditions, the heating effect of the electrical circuit will be formed here. So how we write this? H directly proportional to V into I into T. So this is what? Heating effect of electric current. On which conditions this heating effect depends? On the potential difference, means how much amount of potential difference produced in the circuit, and how much amount of a current is passed in that circuit, and how much time taken in that circuit. So H is proportional to V into I into C. So we write H equals to VIT. We know that from our Ohm's law, V equals to IR. So R equals to, okay, I equals to, how we write? I equals to V by R. Before writing that, we have to take the power. So in this case, we take a V here. So this is a potential difference. But this potential difference is formed from the power supply. So how this power supply depends? This power supply is produced as it is a V into Q, means how much amount of a potential difference and the current passed to the electrical circuit, and in the time interval of a T there is a power produced, that is P equals to V into Q divided by T. So this is what the power supply. Okay, so we have another formula too. We can, using this equation, we are going to apply in this heating effect of a electric current. So we are going to apply this V value in this heating effect of electric current. So what happens? H is equals to, V means it I into R. So I into R into I into T. So that will be equals to I square R into T. So this heating effect of a electric current is the proportional to the electric current, means square of the electric current produced in the electrical circuit, and resistance means it is proportional to the resistance of the electrical circuit and the time taken when there is a electrical circuit will be formed. So this is nothing but the H is equals to I square into RT is nothing but the Joule's law of a heating effect. Okay, so what is the statement of this Joule's law of heating effect? So it states that the heating effect of the electrical circuit is directly proportional to square of the electrical circuit and directly proportional to resistance of the electrical circuit and the time taken by that electrical circuit for the formation of a heating effect. So this is all about the heating effect of a electric current. In the problems, they will give you the resistance. Okay, so they will give you the resistance, current and the time interval so that you can calculate the heating effect, and they will give you the power P equals to V by Q. So this V by Q by T is nothing but the I. So that we can write here. Okay, Q by T also. So we may also say that H is directly proportional to Q by T, and this H is also proportional to power supply, means how much amount of a power is produced inside this electrical circuit, that much amount of a heat will be produced. So these are all the some formulas or some conditions for the heating effect of a electric current. If they given you some conditions, you will able to solve the problems based on this electrical current. So the next is the electric power. So in the 9th standard you have studied about the power. What is the power? The rate of doing a work is nothing but the power. So we can write P equals to what? W by T. So we know that I will be produced from the charge into T, means electrical charge produced in the cross-sectional area in unit time, and we have a V equals to W by Q, means work done in electrical charges. Okay. So this is V equals to W by Q. So we can tell the definition of electric power as a rate of consumption of energy, means how much amount of energy is conserved in the electrical circuit, that is nothing but the electrical power. Using all these equations, we can have a one formula, right? So we have a Q here and Q here. So we will going to apply this Q value in this equation. So we will write Q equals to, okay, I will take in here. Q equals to, we will write W by V, and I put this Q value in this equation, that is I equals to, Q means what? W by V, and put this T here as it is. So I equals to, okay, W by T means what? V here, and put this V as it is. So power, electric power equals to what? V into I. So this is what the formula for a electrical power, that is V into I. So the rate of consumption of energy in an electrical circuit, nothing but a electrical power. So we put the V value from the what? You can using the Ohm's law. V equals to IR. We can write P equals to V means IR. We can write I square into R, or P equals to I means what? Okay, V equals to IR, right? So I value becomes what? Wait, V square divided by R. So this is what electrical power in terms of what are the terms? Power in terms of potential difference and electric current, electric current and resistors, and a potential difference and a resistor. When the conditions are given, you can observe it very carefully and you can calculate the electrical power. So what is the unit of electric power? As you all know, watt. So this is the SI unit of electrical power. So this is what all about the electricity concept. If you have any doubt in all these concepts, you can ask me. I will clarify all your doubts. So this is there for your syllabus. Go through the problems in your textbook. What are they? If you have any doubts in the textbook problems, you can ask me. I will clarify you again. Okay. Thank you, students. In the next class, I will take the next lesson, magnetic effect of electric current.